Hi, this is Paul again. I've got something new to show you. I've revised 3D Platonic Order Lesson 1 to 6. The original lessons were made about 10 years ago, and the sound is missing of some of the lessons. I've also managed to improve the definition, so I hope you'll like these new videos. The original videos were all snubbed and given the cold shoulder, but people are beginning to realize that 3D Platonic Order is very important. And the academics that teach chaos theory are slowly beginning to change their mind. Okay, let's start with lesson 1. Okay, in lesson 1, I'm showing you a size 6 cubic wonder. Now you can see it's turning along the edge of the dodeca at an angle of 0 to 44.6 degrees. Now I'm also showing it going around the wider gap, which is 75.4 degrees. Now the difference between 44.6 and 75.4 degrees is exactly phi, the golden ratio. I'm also showing 6 Bucky cubes and 6 Plato cubes as a diagonal. So the dodeca is made up of a nest of 5 cube outlines, all golden ratio to each other. Now if you take the measurements of the 44.6 and 75.4 distances, they're exactly golden ratio to each other. Okay, that's lesson 1 for you. Let's go to lesson 2. Okay, I've shown in my videos on cubic wonder is that the Bucky cube and Plato cube are made up of 8 Chico and Chica cubes. Now in this lesson 2, I'm showing you that these Chico and Chica cubes can be sliced away like layers, and you can see it running along the diagonal perfect symmetry. Now I showed that these layers can be turned on and off with a digital signal. Now if you look at this cube rotating around, you can see that it can be sliced on 3 faces. That is how I say it can be sliced by a 3-phase signal. Now I show that different signals can control the Chico and Chica cubes to show different orientations or different numbers of cubes. I guess we're looking at pretty advanced stuff here. Maybe this is why the mathematicians said only a crank would work with trivial geometry. They come up with similar stuff about the Wright brothers, about getting something heavier than Earth off the ground. I guess nobody's perfect in this world, only mathematicians. Anyways, we'll keep this animation going to the end, and you can see the different configurations. Maybe one of these days, the academics are going to say that chaos theory isn't very good, and they should turn to 3-dimensional geometry. That will be the day. In the last 15 years, not one academic has mentioned the words cubic wonder or quad-step ball ring system. They all seem to focus on 2-dimensional tiling. So this brings us to the end of lesson 2. Okay, let's move on to lesson 3. This is interesting. In front, I'm showing you a dodeca, and I'm showing you a phi rectangle. Dodeca is made up of many phi rectangles. So let's focus on the measurements of this phi rectangle. Now if you look at measurement A, it's 600, which is the length of the edge of a size 6 cubic wonder. Now you can see I'm showing the details of the measurements of this phi rectangle, and it's perfectly golden ratio. Okay, now I'm going to show this phi rectangle inside a size 6 dodeca. Now inside I'm showing a size 1 icosa in the center. I'm also showing 20 vectors on each vertex of the dodeca. Each vector is 2 colors, and these are the colors of the cubes, the nest of cubes. Now if you look at the diagonals of the rectangle, the colors of the vectors match the faces of the icosahedra in the center. Now I'm going to show a cyan phi rectangle, and you can see how it's orientated to the other one. Now I'm going to show in purple what I call the Yucatans. The Yucatans are made up of a longer edge and a shorter edge, 120 degrees about. And they are exactly golden ratio. So this brings us to the end of lesson 3. Okay, so now we'll take a look at lesson 4. Now in front I'm showing you a size 6 cubic wonder. Now with cubic wonder, what's amazing about this is that you can slice down in different vectors. Now if we slice the corners, we end up with a cube octahedron. You can call it truncated as well. So now I'm going to repeat this anim, going from a 6, 5, 4, 3, 2 and 1. Now what's amazing about the cube octahedron, it will morph into an icosa. So I'm showing them morphing into icosas as well. Now this is a very important feature in 3D Platonic order. It goes from a 3-fold and 4-fold into a 5-fold. Now if you focus on the icosa, it'll break down into 20 pyramids. Now this anim will show that the pyramids will go from size 1 to size 6. Nobody shows any interest in this type of thing for bonding geometry. Maybe 3-dimensional order is forbidden by the peers. Anyways, I think this is the end of lesson 4. Okay, now we'll take a look at lesson 5. And in this lesson, I'm going to show the morphing and how the cubes line up in the diagonal, going from size 1 to size 1 cube octahedron to size 1 icosas, and show 7 in the string. I also show the long diagonal of the size 1 cube, which is 173.2, that's root 3. I have also showed these icosa strings turning into B-type DNA in some of my videos over the years. Notice that I called this string the snub knot string, and this is exactly what academics done. They snubbed it from the face of the earth. Now we can move on to lesson 6. Now in this lesson, lesson 6, it shows that the size 1 can also be a size 3, and I show it morphing to the outlines and to the cubes, and you can see it splits into 3 sections. It shows these 3 cubes splitting into the cube octahedron and then to a size 3 icosa, and it shows the icosa lining up perfectly in 3 sections to the size 6 cube. What I'm trying to show here is the amazing interrelationship to different sizes of cubes and icosas and sacred geometry. It's not chaos. It doesn't matter how many PhDs these guys got. It's not chaos. Anyways, I was going to revise lessons 1 to 10, but it's getting a bit long. So I think I'm going to call it a day on lesson 6.